Hi, this is just a brief tutorial on solving polynomial inequalities. In this lesson, we're going to look at some roots of the polynomial equation, specifically real roots, and then we're going to determine solutions to polynomial inequalities, and we're going to write them, the answers, in an inequality rather than an interval form. So I'm going to give you two graphs here. And we're going to start with the one on the left, problem number 1. It says, find the set of x values to represent when the graph, or when the polynomial, p of x is greater than 0. So first I just want you to look at the graph and recognize that when they say 0, they're referring to, again, the x-axis, and there are 2 points that are the zeros. Again, zeros are where they cross the x-axis, and those are real values. So obviously that occurs at a positive 2, and this happens to be a negative 0.5. And so when you look at the graph is above 0 right here, and the graph is greater than 0 in this section. And so the way that we write those solutions out is, again, it's always referring to the x values. And what we did last chapter is we wrote it in interval notation. And we recognize that the graph, if it's going sort of this direction, it's heading towards negative infinity. But when we write it as a solution, we talk about the x values, and all of the x values are less than that negative 0.5. Whenever the x value is less than negative 0.5, like negative 1, the graph is positive. If it was negative 2, the graph would be positive. Likewise, the graph is positive or greater than 0 in this whole section, from negative 0.5 to positive 2. And so we read this from right to left, and what we say is, we say, okay, negative 0.5 is the lowest x value in this section of the graph, and the graph falls between, so we put the x between those two x values. So the graph falls between, again, that negative 0.5 and that positive 2. So my solution set to question number 1 is, again, that x is less than 0.5, and that x is between negative 0.5 and positive 2, and we read that as negative 0.5 is less than x is less than 2. And notice that the inequalities are both pointing towards the smaller value. They will never point in opposite directions if you have what we called a compound inequality. So that's how you do a question like number 1. Question number 2, same idea. You want to identify your zeros first. So we have a 0 at negative 4. We have a 0 at negative 1. We have another 0 at a positive half. And we have a negative 0 at a positive 2. And in this graph, when you look at it, we're looking for values that are, again, greater than 0. So very similar to this graph, it just looks a little different because this is more of a even exponent. So again, greater than 0 would be this part of the graph, greater than 0 would be this section of the graph, and greater than 0 would be this section of the graph. And again, just like we wrote our interval notation, we recognize that the graph continues to go to the left on this side, and the graph continues to go to the right on that side. And so when we write our interval notation, if I'm referring to this first section on the left, all of my x values are less than that negative 4. The x values will continue to get less than. So that's why we have x being less than negative 4. For this section right here in the middle, my x values are between negative 1 and positive 0.5. So again, we write that as negative 1 is less than x is less than 0.5. And then the third section, we know that the graph again is continuing to the right, and the third section starts at 2, and that all of the x values continue to get larger because the graph is moving to the right. So this is two examples of, again, solving polynomial inequalities when you're trying to figure out if they're greater than 0. If you have any questions, please stop in. This is similar to what you were asked to do on your 5.1 homework assignment.